Hello friends, welcome to my YouTube channel Mech Maharashtra. Gives you educational videos, so do watch, share, like, subscribe. Clear? So last point we have seen about the condition, that is type of belt drive. Now we'll start with the speed ratio. So as we have seen in difference between rigid and flexible belt drive, the speed ratio many time in case of the belt drive is not constant, it will be varies. So what should be the speed ratio? How we can calculate that speed ratio? So that we are going to learn here. Now you can see one by one. There are two types basically, by neglecting slip and considering slip. So if we neglect the slip, then there will be the some velocity ratio, that is speed ratio, and in case of the considering also. So I'll start with the neglecting slip. You can see here the speed ratio is nothing but, of course, speed of driven pulley divided by driving pulley. Now I'll explain these things. The diameter of driving, that is smaller pulley, small d, bigger pulley, capital D, a small n, RPM of smaller pulley, big N, RPM of bigger pulley. Velocity, small v is the linear velocity of smaller pulley, capital V is bigger pulley velocity, and this VB is nothing but the linear speed of the belt on that pulley. VB is linear speed of belt. So we'll consider the velocities. See, linear speed on the velocity on the belt is equal to, of course, velocity of smaller pulley as well as a bigger pulley, definitely. Then I'll convert this. As we know, is velocity is equal to pi dn. So for belt velocity, I have written here pi dn. This small d indicate for small pulley, capital D indicate for bigger pulley, small n for smaller pulley, bigger RPM, capital N. So through which we'll get the equation, that is the diameter of smaller pulley divided by diameter of bigger pulley is equal to RPM of bigger pulley to the RPM of smaller pulley. Correct? So that we can say that this will be the speed ratio. So we have written over here. You can check that we can convert anytime. So you can see capital N by N in terms of the speed is equal to small d by capital D. If I add the thickness, neglecting slip, so speed ratio would be N is equal to same equation, but just add plus T. So if I add the thickness, that would be your speed ratio with respect to belt thickness. So speed ratio is equal to N by N D plus T divided by capital D plus T. Simple. Clear? This is the first type, by neglecting the slip. We'll move toward the considering slip. What happen in case of the considering slip? Just consider there is the indication, two pulleys are there, it means two slips are there, S1 and S2. So we can say S1 is the for the smaller pulley and S2 is for the bigger pulley. You can see here, these S1 is the nothing but slip percentage between driving pulley and belt, that is smaller pulley and belt, and S2 is the slip percentage between belt and driven pulley, that is bigger pulley. Correct? So second, output pulley. So this will be the percentage of the slip we can consider, because slip we need to calculate in the percentage. Then the linear speed of the belt considering slip between driving belt and driving pulley and belt. So first we can say that is S1 related with the first pulley by considering the driving pulley and belt. You can see pitch that VB, that is belt velocity, is equal to smaller diameter pulley, that is small v, minus slip of that respective pulley S1 by 100 into velocity. So this will be the equation for velocity, that first of all we have to consider velocity and minus the velocity with respect to slip, that is V minus S1 by 100 into V. So we get common and we'll get the relation V into 1 minus S1 slip of first pulley, that is smaller pulley, divided by 100. So I'll convert this. V is nothing but pi dn by 60 and 1 minus S1 by 100. This would be your first equation related to driving pulley and belt linear speed. Clear? Next. Now we'll see one by one. Now we are going to check for the pulley situated between belt and driven member, that is second pulley, belt and driven member. You can see this. Now what happened here? The velocity, bigger pulley, is equal to, we can write direct. Why this bigger pulley comes in picture? Because the velocity we need to calculate for bigger one. That's why bigger pulley is equal to belt velocity, because up to driving to belt we have calculated in previous slide. Now we need to calculate belt to second pulley. That's why VB minus VB of S2, that is second pulley slippage, S2 by 100. Therefore, VB get common and we will get the equation VB into 1 minus S2 by 100, that will be the second pulley. Now, we are interested in VB, belt velocity, because previous slide also we have calculated. So, VB is equal to V by, you can see this equation, V by 1 minus S2 by 100. V is nothing but pi dn by 60. You can see this, pi dn by 60 into 1 minus S2 by 100. This would be the equation of B, second equation. Now, if I equate the 1 and 2 velocity, that is VB of smaller as well as a bigger pulley, that is VB of smaller and bigger, you can consider by equating this, I will get pi dn S1 in pi dn divided by 60 in bracket 1 minus S1 by 100, equation 1, and this is equation 2. After equating it, I will get directly the d by d, that is smaller pulley divided by bigger pulley in bracket 1 minus S1 by 100 into 1 minus S2 by 100 is equal to RPM of bigger pulley divided by RPM of smaller pulley, correct. So, this will be the ratio we will get from the equation. We will see the speed ratio, this is n by n, which we have calculated. So, n by n is nothing but same term I have repeated here, n by n is nothing but d by d in bracket 1 minus S1 by 100 into 1 minus S2 by 100. So, d by d get common and multiply this term 1 by 1, and after multiplying the two bracket, we will get this, and we need to convert that d by d is equal to 1 minus S1 plus S2 by 100. This would be the equation final, because we are neglecting this S1 minus S2, because subtraction is not used here, actual application, that is why we will have to neglect it. Therefore, our equation is, in case of the speed ratio, that is d by d in bracket 1 minus S1 plus S2 divided by 100. So, of course, S1 plus S2 means total slip. So, therefore, I have written here, that is total slip is equal to d by d, instead of S1 plus S2, capital S, total S, that is 1 minus S by 100. Therefore, speed ratio of belt drive is d by d 1 minus S by 100. So, this is speed ratio in terms of thickness, because previously we have considered that would be small d plus t, capital D plus t, in bracket 1 minus S by 100, clear. So, this would be the final derivation for the speed ratio. So, likewise we need to derive the expression for speed ratio. I will revise what the points which we have covered in this session. In this session we have seen the slip ratio, that is speed ratio, by considering slip and neglecting slip. In case of the considering, we have considered the pulley which is situated in between driving pulley to belt, and in case of the neglecting slip, we have considered the pulley which is situated in between belt and driven pulley, through which we will get the two equations. So, these are the two equations. After equating this, this will be the equation we got, and this will be converted, and a final equation would be this after neglecting this minus slippage. So, total slip ratio is d by d in bracket 1 minus S by 100. Clear, friends? I hope you understood. Just write it on a paper from your side. After watching this video, you will remember what is going on. Clear? We'll see next part in coming lectures. Thank you.